Let's dive into linear and exponential growth. Understanding the difference between linear and exponential growth is going to be key for the SAT. Now, the difference all lies in how the rate of change behaves. Linear growth, the amount of change is going to be the same for each equal interval. If we graph it, it's always going to give us a straight line. It's going to follow the pattern y equals mx plus b, where x and y are independent and dependent variables, m is our slope, and b is our y-intercept. It's always going to be a straight line when we graph it. For example, if we say earning $15 per hour, that means every hour we're going to get exactly $15. Now, exponential growth is going to be a little bit different here. The amount of change itself is going to increase and decrease. Instead of being a straight line, it's going to be more of a curved line. It's going to curve upwards or downwards. The formula for this is going to be y equals a times b to the power of x. A is going to be our initial value, b is our actual growth factor, and then x will be the time that progresses usually, or the independent variable here. For example, we could say money in a savings account with compound interest would be a good example of an exponential growth. We can also take a look at driving, for example. We know that we put our foot on the gas, we're going to increase over time and our speed is going to increase. The same way if we slow down, our speed would decrease. But let's say we're slowly putting a little bit more pressure on that pedal over time. That's going to form our exponential graphs. Let's go ahead and look at an example here. Let's use a table with the following values. We'll go from 1 to 4, and then we'll start with 50 and increase all the way up to 70. We can say this is time and maybe gallons of water filling up a container. Taking a look at this table, we notice that we're always gaining 5 for each increase of 1. So the rate of change between these 2 points is going to be 5. But let's say we didn't have a nice table like this. Let's say they just gave us the points. Let's do 7, 48, 12, and 56. How are we going to find the rate of change with these two values? Well, we have an equation we can use called the slope equation. And this is going to tell us the rate of change. The equation is as follows. It's going to be m equals y2 minus y1 over x2 minus x1. And then we plug in our values respectively. What we choose to be x1 or x2 or y1 and y2 do not matter as long as you keep the x's and y's paired together. So I'm going to set up my equation here. I'm going to say 56 minus 48 over 12 minus 7. And then we're just going to simplify here. I know 56 minus 48 is going to give me 8. I know 12 minus 7 is going to give me 5. Every time I increase by 1, I also increase by 8 over 5 for the y. Now, when we're looking at exponential growth, it's a little bit different. The most important thing is to try to keep track of the actual growth factor here. If we had a table and we'll do 0, 1, 2, 3, 4, 5, and then we'll do 100, 200, 400, 800, 1600, and then maybe 3200. If we look at our table here, we're no longer just increasing by our set value. Instead, it looks like our number is doubling here. We know 100 times 2 is 200, times 2 is 400, 800, 1600, onwards. So we know the growth factor here is going to be 2. The most important thing to differentiate between the two is knowing that linear growth is always constant and exponential growth is always increasing by a growth factor.